Okay, good morning, ladies and gentlemen. Welcome in the first session of the morning. I'm introducing you Michel Blancard, who will be our first speaker of the morning. An applause, please.
Excuse me.
Keep going, go down.
Slideshow tout en bas ici.
Ah, ok. Ouais. Thank you. Hello, everybody. So I'm Michel Blancard. I'm a data scientist at Etalab. So to keep short, Etalab is the French Prime Minister's task force for open data, open government, open source, and data science. And we like projects that combine several aspects. And as you will see, OpenSolarMap is all at once because we make open source code that builds open data using data science, contributing to a better awareness of energy management. So what is OpenSolarMap? It's a roof orientation map. So it aims to distinguish north-south orientation to flat roofs to east-west orientation. But what for? It's for estimation of solar energy potential, because you cannot put solar panels on every roof. You prefer north-south orientation, and you can do rooftop greening only on flat rooftops. And which data do we use? Satellite images and cadastre. It's a map in France used for the tax system. If you want to use machine learning on images, typically you need a training set of several thousand images, and then you can generalize on new images. But building a training set usually is a pain, because you either have to do the work yourself, which is quite boring if you do it alone, or you can pay people to do it in Amazon Mechanical Turk or other platforms, but it's really not ideal usually. But Christian Quest had the idea to build a crowdsourcing platform so you can go to opensolarmap.org and you have this page, this web page, and you can click, choose the class of the roof. First class is north-south orientation. Second is east-west. Third is flat roof. And the fourth class is every roof that is complicated or you don't know. Here are a few examples. You can see that some are easy, like the first one on the top, but some are very complicated, and we cannot always decide. Next, after having built considerable training data sets of like 10,000 roofs in 3 weeks, we decided to use automated learning to generalize. And you may think that machine learning is very complicated and only for specialists. In fact, now a lot of algorithms are very well packaged, and you can use it very easily. Like we use two algorithms, logistic regression and neural networks. And to use logistic regression, you basically just have to import the model and use it on your data. So it's literally 3 lines of code. And neural networks, it's the same thing. I just downloaded a snippet on the internet. I changed one parameter. You can see the red box on the top. And I changed a few layers, but it's very light. The work is very light compared to the engineering work used to build these nets. So it's easier to use it than to build it, but it's very well for applications. And if you want to know more, I've written some technical explications on the blog of the team. It's in French, but if you're interested and speak French. So what's the quality of the prediction? Our baseline, our human baseline makes between 1 and 4% of errors, depending of the mood, on 4 classes. You can see the results of the automated learning is not as good, but you don't always want a very good precision in your applications. Here, it's enough to have 80% of correct classification, because we still get new information. And we can analyze the results here. So here you have a map of the percentage of one kind of roof compared to the other kind. And the first kind is better for the solar panel implementation. And you can make an observation. Some regions are have much more potential for solar panel implantation. And you can see some geographical features like the Rhône. Here you can see, and you have in big cities, you can have very extreme values. So this is valuable information for public policies, because if you want to give money to help solar implantation, maybe you prefer to do it on good regions, on regions where the potential is high, compared to regions where the potential is very low. And for rooftop greenings, we have a similar map. You can find that the proportion of flat roofs is higher on big cities and in the Paris region too. So here we used only basic machine learning techniques with no complicated techniques. It was a very light project because we crowdsourced the training set and we used only the first available standard technique, and we get valuable information for public policies. And our project interested some other projects. The winner of a concourse by Fujitsu was a reutilization of OpenSolarMap. It linked solar exposure in France with altitude data and the OpenSolarMap database. And the same challenge was used for the selection phase of the data science game this year. The data science game is an international competition for students in data science fields. And with the work of the teams, the error rate dropped from 20% to 13%. So now we can have even better data with more complicated models. And it paves the way to new challenges, like the same way you could automatically detect bus lanes or special lanes, pedestrian crossings, maybe classify buildings in unmapped area, have classification of land use when the cadastre or other maps are not precise enough, and maybe a lot of other applications we haven't thought yet. So thank you for your attention, and if you have questions, don't hesitate. Yes?
First of all, I really like the idea. Okay. First of all, congratulations for the idea and for the project. I would have 3 questions, but I forgot one of them, so 2. First of all, the images that you are using, what is the source of the image?
Typically, it's 100 pixels by 100, but I resize them to fit the exact size that is needed by the neural network. You can see the parameters are modified with the size, so it's 96 by 96.
Okay, no, but the question was like, are you using like Bing images or Mapbox images or?
Mapbox images, and a big thank for Mapbox because we gathered over 1 million images by their API. So thank you.
Okay, because this is why I was interested. And the second question that I forgot now.
Okay, thank you. My name is Alessandro Lasia from Statistics Canada. I am interested in the crowdsourcing experience of your project. If you can elaborate a little bit more on that and maybe how that happened, how many people you engaged.
Maybe Christian is the best
Thank you.
person to answer your question.
The project has been started and it took different steps. First, I proposed the idea to an open data contest, and the idea has been selected. So I got some money for that. Once you get some money, you say, okay, I need to make it. It's not just stay as an idea, make something. So we wait for the next step. Took place during a hackathon about climate change for the COP21 in Paris. And in one day we wrote the small piece of front end and back end to have the crowdsourcing thing. We just sent a few emails on the French OpenStreetMap mailing list, a few tweets, and within, I think it was 2 months, we had 100,000 contribution. So it helps creating the first data set that then Michel used. And it's really fun to see all the steps one after the other. And the idea at the beginning at that open data contest, the first step was to select the buildings more or less matching the cardinal orientation. And then the idea of having a crowdsourcing interface. And then the idea to have a neural network, to train a neural network. But then we did more, because the first result from the neural network from Michel, I put that as contributions in the crowdsourcing thing, as one or two contribution, waiting for other people to confirm the neural network. So you see, you can do the mix between machine learning and crowdsourcing and humans. And I think it's really interesting. We can really reuse it for many things. One thing that Michel did not say is that once we have enough information about the roof orientation of the building, we push the information back in OpenStreetMap, of course.
I remember the data set, the trained data set, first of all, is available. Can we use it? And second, with the data set, do you know how applicable is, like, if I want to do it for Romania, would it work, or is kind of so many particular differences between them?
First, you can find the training dataset on data.gouv.fr. It's a French platform for open data. Yeah, and second, if you can replicate this project on Romania, if you have satellite imagery and cadastre, it means the boundaries of the buildings. Yes, you can reuse my code and improve it, and yeah, of course.
Maybe using with the OSM building.
Yeah?
Yes.
That building equal house or something.
In fact, that's what we use. The thing is that in France we are importing the cadastre building footprints in OSM, but I extracted the footprints from OSM so that I have the ID of the object in OSM, so we can put back the information in OpenStreetMap.
Thank you. That's okay. I do research in remote sensing, and I want to know, please, for me, solar illumination is a big factor when you do machine learning. So I don't know, is your model take into account solar illumination variation depending on weather, and how much it affects the results, the final results of your model?
We thought about that, but we don't have the date of the photo of the satellite image. So we
don't have that information.
Yeah, we don't have the information about the shadow of the sun or the solar. So no, we cannot use it.
Did you manage to use another source of data to get more accurate information? Free? Yes.
No, we didn't. But the aim of the project was to be the lightest possible. So to show that you can produce valuable information using very, very few work. So we didn't link to other data, but it could be very useful to take the project as it is now and to improve it like the data science game did.
Okay. So you think it will be better if you have this information for your model?
Yeah, if you add some more information, you will have better results. Yeah.
For example, one of the ideas proposed to Michel is we know more or less the orientation, but we have no information about the angle. And I said, but when the roof is really flat, the contrast between the two sides of the roof is very there's not a lot of contrast, but when it's high angle, you have a higher contrast. Could we detect more or less the angle using that information? We have not worked on that, but it's an idea. So it's really a step-by-step project. So what's the next step? We don't know, but okay, if you have ideas, I have some ideas. If you have ideas, it's fine.
Hi, I found it very interesting that that you had lots of these roofs north-south, I guess, for example, in the northwest of France and on the southern coast. Can you do you have any explanation of why that might be, historically speaking? Any insights? Anything you thought about that?
Yeah, in fact, I don't know myself, but I would like to talk with somebody with geographical skills to explain, to correlate these results with geographical features in France. It would be very interesting.
Possible explanations is in the south part, you try not to have too much sun in your house because it's a hot part of the country. And in Britain, it's not that hot, so you're happy to have sun in your house. So maybe your windows are facing more south or something like that. That's maybe an explanation. It may come also from the winds. The wind is usually blowing from west in Britain, and the high wind in the Rhone Valley are blowing from north. So maybe the orientation of the buildings is also linked to that. It could be interesting to mix with weather information to see if we have a relation, but I think the relation are something like that.
One question, did you ever try to filter this data by Christian churches? Because they're should all be orientated east-west, just as an idea.
Filter with what? Excuse
like filter this, but only buildings which are churches,
Yes.
and then see if it's really true that Christian churches are always oriented east to west.
Okay.
They are not, and their roof are usually complex. So it falls in the fourth category with the question mark, because you have a complicated roofs, yes.
Unfortunately, we have to proceed to the next speaker. We're running out of time and we have to keep the tight schedule. If you have any more questions, please feel free to ask them to the speaker directly during the break at 11. Let's thank our speaker.